So as we are discussing about the cell, the basic things to understand action potential. So up to now we have discussed about the reasons of why the cell inside the cell is negatively charged. The first reason is sodium potassium ATPase, 3 sodium efflux with the exchange of 2 potassium influx. Second thing is leaky channels of potassium ions, and the third thing is the protein synthesized within the cell membrane is negatively charged. So because of all the reasons together, the cell is negatively charged. So if you say how much it is negatively charged, so if you take the nerve fiber, nerve cell, the nerve cell is negatively charged nearly around minus 70 millivolts. So the normal resting membrane potential, of a nerve fiber is minus 70 millivolts. What is resting membrane potential here? So the resting membrane potential, so when the nerve fiber is at rest, that means if there is no stimulation or if there is no conformational changes, if there is no proper stimulus to the nerve fiber, so that state we call it as resting membrane potential. So the resting membrane potential of a nerve fiber is minus 70 millivolts. Minus 70 millivolts. Now, once you stimulate the nerve fiber, how this negatively charged converts into a positive charge? How these charges propagate from the periphery of the nerve to the central nervous system? So we have to understand how these peripheral nerves, due to any sensation or any stimuli, how these peripheral nerves are getting stimulated and this propagation of wave reaches to the central nervous system. Say for example, this nerve fiber is towards periphery, and so due to synapse, another set of nerve fibers carry the information towards the central nervous system. Now, the concept we need to understand is how these two nerve fibers communicate with each other, how they carry the information from the periphery. This is periphery. Say for example, I am giving a stimulus to my finger. So my peripheral nerve fibers are carrying the sensation towards the central nervous system, that is towards the spinal cord. So this is the peripheral nerve fibers, and the peripheral nerve fibers are carrying the information after giving any kind of stimulus, like you can say touch, pain, temperature, any kind of sensation. If you are giving any kind of stimulus, then how they are propagating the stimulus towards the central nervous system. So here we must understand one more thing is how the nerve fibers communicate with each other, how the information is carried forward from one nerve fiber to another nerve fiber, because from the periphery it has to carry towards the central nervous system. How they will carry? So if we stimulate some over here, if we stimulate this nerve fiber, the action potential reaches to the nerve terminal. So in the nerve terminal we have a lot of vesicles which stores the neurotransmitter. So once this action potential reaches here to the terminal endings of the nerve fiber, then the vesicles breaks and it releases the neurotransmitter. So regarding this one, we will discuss in detail in neuromuscular junction. So here we will understand only the communication between the two nerve fibers. The vesicles in the nerve terminal, it breaks and releases the neurotransmitter. It releases the neurotransmitter and it binds with the receptors which are present over on the next set of nerve fibers. So in this way, one group of nerve fiber carry to another group of nerve fibers. Then finally, the information will reaches to the central nervous system. Right? So, as we discussed, the resting membrane potential before getting any stimulus, the resting membrane potential of a nerve fiber is how much? Minus 70 millivolts. So we'll try to understand this propagation of action potential, how action potential will be generated. So in a graphical method, right? So the resting membrane potential is minus 70 millivolts. So if a slight stimulus is given to a nerve fiber, so very slight stimulus is given to a nerve fiber, then the graph is ascends towards positivity up to some extent. So this, say for example, minus 60 millivolts, this we call it as sub-threshold stimulus. This is sub-threshold stimulus. So whenever a stimulus is reaching positivity weakly and it is attaining its positivity to some extent and it dies off immediately if the stimulus is at threshold level. If you give another stimulus, a better stimulus, then again once if it is not reaching this threshold level, then this wave is also dies off. So these kind of subthreshold stimulus, we call it as graded. These are graded potentials. Now this time if you are giving a better stimulus, strong stimulus, a threshold stimulus, this we call it as threshold stimulus. So up to now what we have seen, these are subthreshold stimulus. No matter what you give the subthreshold stimulus, so the wave will reach to up to some extent and it will dies off immediately. So these potentials we call it as graded potentials or local potentials. Graded potentials or local potentials. So this time it will give very strong stimulus. Strong stimulus. What happens? And this time the graph reaches to the threshold level, that is minus 60 millivolts. Once it reaches the threshold level, that is minus 60 millivolts, what happens within the cell? Say for example, this is the cell, this is the cell, this is the cell. Once the threshold stimulus reaches minus 60 millivolts, the mechanical sodium gates will be opened. The mechanical sodium gates will be opened. The mechanical sodium gates will be opened. So few mechanical gates will be opened. So later on, so what happens when these mechanical gates will be opened? Then, so I will draw here. Imagine this is the cell membrane. So initially, when you give the strong stimulus, when it reaches to the threshold level of minus 60 millivolts, initially the mechanical sodium gates will be, or channels will be opened, and there is influx of sodium ions. So the initial positivity is due to opening of mechanical sodium channels. Later on, it reaches to the peak. The graph reaches to the peak. That means what? The nerve fibers attains more positivity because of opening of voltage gated channels. So when it reaches up to minus 60, that is at the threshold level. Once it reaches to threshold level, the voltage gated channels will be built. So these are voltage gated channels, also we can say voltage sensitive channels, we can say. So once it reaches to minus 60 millivolts, the voltage gated channels will be opened and there will be a sudden rush of sodium ions inside the cell membrane. So what happens? Finally, altogether, the positivity increases inside that means anions increases inside the cell membrane. The positivity increases. You can see from minus 70 millivolts, this we discussed as resting membrane potential. So once it reaches to minus 60 millivolts, that is at the threshold level. So this initial part is due to opening of mechanical sodium channels. Once it reaches minus 60 millivolts, the voltage gated sodium channels will be opened and there is a sudden rushing of positive ions inside the cell membrane, that is sodium ions. So this positivity reaches up to plus 35 millivolts. So this plus 35 millivolts, we call it as equilibrium potential of sodium ions. So this is minus 40, 0 plus 20 millivolts, and right. So this is, by this graph we can understand that the positivity increased inside the cell due to mechanical opening of sodium ions and voltage gated channels of sodium ions. Now, so this we call it as this phase. We call it as depolarization. So this one, phase 1, we call it as depolarization. Depolarization. So here, when it reaches to plus 35 millivolts, during this phase, from this threshold level to the peak that is the equilibrium potential, that is plus 35 millivolts. See exactly what happens. If this is the cell membrane, the sodium channels will be having two gates, that is, this is inactive gate, another is active gate. Inactive gate and active gate. So initially, when it reaches to minus 60 millivolts, before it reaches to minus 60 millivolts, the activated sodium channels, voltage gated sodium channels, will remains closed. So once it reaches which is less than minus 60 millivolts, and once it reaches minus 60 millivolts, what happens? The active gates of sodium channels will be open, and this inactive gates is already open. So before that we can see the active gates of sodium channels will remain closed. Once it reaches the threshold level, the active gates are open and there is a sudden rushing of sodium ions. So due to sudden rush of sodium ions, the positivity increases up to plus 35 millivolts. And this is the equilibrium potential of sodium, that is plus 35 millivolts. No matter what kind of stimulus we give, it reaches only up to the equilibrium potential, not more than that. Then, once these gates are open, and when the graph reaches, then the positive ions reaches the equilibrium potential, that is plus 35